Alright, finally I'm going to go through the review for Module 23 and 24. This one is pretty quick for most of the questions because we're just going to be plugging into the DESMOS calculator for most of it. And there's a lot to work out. They didn't really explain a lot of the equations on how to get to it the hard way. You could sit and look through the book if you wanted to, but for the most part they just recommended using the DESMOS calculator and finding the answers we need. Once again, we will be referring back here for this lesson for the law of cosines. So this is something that they give us. And then the unit circle, I'm not too sure. I'll refer to it maybe a little bit, but not too much. Alright, so for this first question, it's just a matter of plugging in our terms into the DESMOS calculator, which I have done. We have cosine of theta, or cosine of x plus 1 equals 0, so we want our y to equal cosine of x plus 1, y equals 0, and that'll give us all of our intersect points. So we just click on the graph that we want, and we're looking for the points between 0 and 2 pi, which it does intersect, it doesn't equal 0 at the y-axis of 0, so we don't count that one, but we do have 1 pi, and our next one is 3 pi, which is more than we need. So in order to find it within this realm, our graph just gives us pi, and that's it. Once again, this one's just graphing with the DESMOS calculator. You plug in y equals secant of theta, y equals 5/4, and we are not going to get exact answers. We're going to get decimal answers and round to the nearest hundredth. So here, once again, between 0 and 2, we're going to go to where our lines intersect. Since this is the secant, we're looking at where x is going to equal the intersection, which is going to be 0.64. 5.64, but that is it because we're not going to include 2 pi, so anything after that we're not looking for. And that gives us the answer 4. Alright, so problem 5 is slightly different. Still using the DESMOS calculator, but this time we're looking for all solutions to the equation, so that's where we use these funny looking symbols. The way we do that is 2 times cosine of x plus square root of 2, and then y equals 0, which mirrors what we have here. And so what we want is we have, well, it just went away. Look at that. We have 3 pi over 4, 5 pi over 4, 11 pi over 4, and 13 pi over 4. And so this is going to have two different answers. One of which, since we see 3 pi over 4 here and 11 pi over 4 here, we can do 11 minus 3, which is going to give us 8. So 8 pi over 4 is going to equal 2 pi. Same with 5 and 13. 13 minus 5 is 8. 8 pi over 4 is 2 pi. And so these points are exactly 2 pi away from each other. But since we have 2 points in one period that intersect our y equals 0, we have to include both of those points. So it'll be 3 pi over 4 and 5 pi over 4 that we end up plugging in here. So we get 3 pi over 4, and then we're going to add 2 k pi kez, and then 5 pi over 4 plus 2 k pi. And what this is this k number is just how many intervals we're looking at, because no matter what whole integer you plug in here, it'll make this equation true. Same with this. If you go -2, if you go +2, it's always going to take you down 2 pi. You go -1, plug it in there, it'll bring you back over to this point. Likewise, bring you back over, actually brings you over to that point, not that point, but so on and so forth. So pretty easy. Now we go back to finding the solutions inside of the interval circle, which these get more complicated. Once again, I never really explain in depth how to do it, just kind of tell you to read the book on it. And so they encourage you to use the DESMOS calculator, so that's what I did. You plug it in exactly like so, and anything less than between 0 and 2 pi you can use. So pi over 4, 3 pi over 4, that's going to be our answer. Gotta love these problems. Just to show you again, simply plug that in exactly how it is into the calculator, and you do your equal side as -1. It gives you all your intercepts between 0 and 2 pi. So that's going to be pi over 3 and 5 pi over 3. And that's all we got to do with this one as well. So for this, I really feel like the graph is pretty cool. But plug it straight in. What you have here, y equals 0 at point 0, pi over 3, pi, 5 pi over 3. So those will be all your solutions here. 0, pi over 3, pi, I think it was 5 pi over 3. 0, pi over 3, pi, 5 pi over 3. There you go. Alright, so this is the first point on this review in which we have to do actual math. And so this question 9 has frustrated me time and time again because there's little nuances that you have to remember that I've had to make sense to me myself. And so all we have to do is plug in the information we have, and we're looking for angle theta right here. And so we're going to plug in 457 right here, and then we're going to plug in the 160 right here, and that's going to give us 457 equals 160 squared times sine of 2 theta all over 32. So multiply by 32, multiply by 32. Those will cancel out. This will give us 457 times 32, which is actually, let's find that out. 457 times 32 is going to be 14,624. And then, since we just have this function now, because we crossed out 32, we're going to divide both sides by 160 squared, which will give us that equals the sine of 2 theta. And so from that point, we will do our answer divided by 160 squared. I like to keep it in fraction because it's more precise, and the fraction that it gives you is really 457 over 800, which I had my calculator just break that down, equals your sine of 2 theta. Going to do the arc sine of both sides, so you're going to end up with the arc sine of this. It's going to cancel out this sine, which will leave you with 2 theta, and then you divide it all by 2. So if our sine, well, we'll get to that here in a second. So to give this answer in rads, you want to make sure your calculator is in radians, and what we're going to do is take the, first of all, erase a lot of this, and what we're going to do is take the inverse sine of 457 over 800. It'll give us that, and then divide it by 2. And that's going to give us 0.30 radians. Or, now another thing we have to do here is we can go look at the unit circle. So our sine is positive, right? So since our sine is positive, since our sine is positive, then our y value is positive. So our y value is going to live up here. And it can either be, just for example, this one or this one. So what this equation gives us is the angle off of 0. And so now what we need to find is the angle off of pi, which is going to be pi minus our equation right here. And so what we're going to do now is we're going to take the pi, subtract the sine, or the arc sine of 457 over 800, and then also divide everything by 2, and that'll give us our second answer. So come back over here, we're going to do pi minus the arcsine 457 divided by 800, and then divide all that by 2, is also going to give us 1.27 radians. With this equation, it's essentially kind of what we did in algebra when we did the inverse equations with the exponential functions and things like that. It's just we have to visualize this on a graph, and with that graph, we can determine where we add and subtract our equation from pi. And so that was the trickiest part. But essentially, we want to make this equation equal 180. And so it'll just be the 180 equals the 143 plus the 62 of sine over, or 2 pi over 11 times t. And so just like with everything else, we subtract 143 from both sides, which is going to, I don't feel like doing arithmetic, especially after taking that trig exam. So just be the 180 minus the 143 gives us the 37. And so our equation is now 37 equals 62 sine of 2 pi over 11 times t. And in order to do this, we separate the 62 from the sine by dividing by 62 on both sides. So cancel that out. And it doesn't want us to round any computation, so we'll just leave it like that. In order to remove the sine from this equation, we have to take the inverse sine so that those cancel out. And then we're left with the inverse sine of 37 over 62. And now we have to figure out what to do with this equation. So just like with the other ones, we're going to multiply this by the inverse of 2 pi over 11 to separate it from the t value, which will look like t equals 11 over 2 pi times sine, arcsine, of 37 over 62. Honestly, the sines are easier than doing the cosine values on this, because this is where we run into the trouble. So for the sine function, you have the main equation here, and you're going to just plug this directly into your calculator as it is in radians, and that'll give you one answer. And to find your other answer, you're going to have to put pi in here and subtract this equation after your 11 over 2 pi. And so it goes in the brackets with this. And the reasoning for that is because when you found this angle of, or this, sorry, I got a little distracted. So the reason we do this is because if we visualize it, we have our unit circle, and with this being a y value, because it's sine, our y value is positive. It's not negative. So it's not going to be down here in quadrant 3 or 4. It's going to stay in quadrant 1 or 2. And so you can assume that it's somewhere maybe here and maybe over here. These are the two values that you're looking for. So for the sine value, the reason you do pi minus sine is because this angle is your pi, and then you're going to subtract what you're looking for. And you do it without the pi for your second one, because you go from 0 to the angle you're looking for. And so what was tricky for me was to also figure out that if this was not sine but instead cosine, normally it's going to give you this answer in a negative. And so when your x values are negative, then you're going to be in quadrant 2 or 3. And so it's looking for this and this, which means you're not going to have just this function here multiplied by your cosine. You're only going to have pi minus that function and then pi plus that function. But if it's negative and you put it in an arc cosine, it's no longer negative. It needs to always be positive, and that's something that tripped me up. But regardless, for this answer here, we can just plug in this equation straight into the calculator. Go ahead and get rid of all this stuff. And then we'll just have that 11 over 2 pi times pi minus the sine, the arc sine of 37 divided by 62. And that will give us, I swear, it's class, man. So then it is 3/8 because it's not the 10th. That was my bad. And I'm pretty sure that one was 1/1. 1/2. Now we can check it out. So there you have it. Alright, so now we're back to plugging the graphs into DESMOS, looking for all available answers or all possible answers to the solution. So I went ahead and plugged this graph directly into DESMOS, and this is what we get. We get 7 pi over 3 and 11 pi over 3. And, that's the first dip. So that's one revolution of our circle. And now we go over here to the next revolution. We have 7 pi over 3 compared to 19 pi over 3, which is 12 pi over 3, which is 4 pi. And then 11 pi over 3 compared to 23 pi over 3 is 12 pi over 3, which is also 4 pi. So our equation is going to be 7 pi over 3 and 11 pi over 3. 7 pi over 3 plus 4 pi, or 11 pi over 3 plus 4 pi. Remember, you don't have to put pi after it because it gives you the k variable, any whole integer, plus pi, or times pi. So that's 80 down. Okay, now we're getting into the laws of sines and cosines. So for every one of these, I always start out with writing my big A, big B, big C, little a, little b, little c equals, to make sure I get everything organized properly. And so my little b angle is 27, or length. My big B angle is 96 degrees. And then my C length is 52. So I'm going to go ahead and calculate this with the law of sine, but right off the bat, I don't feel like this is going to be a real triangle. I feel like this is going to be one of those it's no solution, just because the largest angle that you have needs to be the largest side, and this is a pretty big angle for these other two to make up. Actually, it's the biggest angle because the other ones won't be able to be larger than 96. And so since C is my largest side according to this, and B is my largest angle, it's not going to match up. But we'll go ahead and run it through the law of sine and see what we come up with. So the law of sine is the fact that sine B over little b is going to equal sine C over little c. And with what we have, sine for B is going to be the sine of 96 over 27, which is supposed to equal the sine of C's ratio over 52. So what we're going to do is multiply both sides by 52 times 52 times 52. Just going to cross those out, and then that's going to give me a 52 times the sine of 96, which is 51.75. Divide that by 27. And so we're supposed to take the inverse sine of this number, which with this number being as large as it is not going, it's going to be undefined. And so take the inverse sine of that equals undefined, which tells me that this circle has no solution. Now, or this triangle has no solution. And so if it did have a solution, this is the same pattern we would use. We would multiply the bottom number over here, take the inverse sine of whatever we get, and then that would give us our angle of C. And then we would take 180 minus 96 minus whatever our angle of C would be, and that would give us our angle of A, which we could then do the same thing, do the law of sine with the B function and compare it to the A, compare it to the A's, and then we would get our final side length as well. But as of right now, this one has no solution. So same thing as last time. We have the law of sines, but in a word problem. And so to me, this is no different. I go through, I mark all my angle letters and then all my side letters, and then work it out from there. This one marks all your angles. So my big angle of A is going to be 51. My big angle of B is going to be 71. And my side of C, since it's directly across from C, is going to be 190. And so at this point, I am going to be looking for the distance from Charlie to the house. So I'm looking for this distance over here, which is going to be my A mark that so I can see it better, but it's going to be my A distance that I'm looking for. And so if I want to find the A distance, how am I going to do this if I don't have anything to compare it to? Well, it gives us two angles, so we can infer the third angle by just doing 180 minus the first angle of 51 minus the second angle of 71 to give us 58. And so we know that the C angle must be 58 because all the angles inside of a triangle must add up to 180. And so now that I have a complete C angle, I can just use the law of sines, which is going to be, if I'm looking for this angle, I want this angle to be on, I want the side length, not angle. If I'm looking for this side length, then I want this side length of my comparison to be on top. And then the sine of 58, it's a terrible 8, to be here on bottom. And then that's going to equal whatever I'm looking for over the sine of 51. And so in order to do this, we plug it in the calculator. You just move this sine over here and multiply it, and that crosses it out from this side, which would be your 190 times the sine of 51 equals 147, and we're going to divide that by the sine of 58. So now we just have done this function, which gives me a number of 174.1. And that checks out because we do want it to be smaller than this side length because our angle is smaller. And so this seems like a plausible solution. So 174.1. And that is good there. Alright, so this one we're also going to use this law of cosines. And just like with all the other ones, I do A, B, C equals, equals, equals. And this just, once again, helps me keep things organized. But for this one, we are given all of our sides, but none of our angles. And so for this one, we definitely have to use the law of cosines. So I'm going to make this angle A, angle B, and angle C, just to keep track. So then this is going to be side A, it's going to be side B, and then this is going to be side C. And so just so I can kind of help keep track of what's going on there, my side B is 277, my side C is 262, and my side A is 169. So I'm going to start by finding the angle B just because it has the longest side. So let's go over here. And to find the angle B, I am going to plug everything in. So that's going to be 277 squared equals 169 squared plus 262 squared minus 2 times 169 times 262 times the cosine of my B angle. So in order to get this, we're going to subtract both sides by the 169 squared and by the 162 squared. Essentially just moving those over here, subtract it, move that one over here, subtract it, and go back and grab my calculator. That'll give me 277 squared minus 169 squared minus 262 squared is equal to that. And then we're going to divide that number by negative 2 times 169 times 262, giving us 0.231. And so after we have that, all this together, all we're doing is dividing it by what's in these parentheses so that we can free up the cosine. And so we have that number equals the cosine of B. And so the way we separate the cosine is we take the inverse cosine. So I'm going to take this number, do the inverse cosine, equals 76.63. Didn't really give myself a lot of room. So I know my B angle is a 76 equals 76.63 degree angle. And what I really want to know is my A angle. And so in order to find that, I know this is my B angle in degrees. Now we can revert back to the law of sine, which is going to tell us that we know A is 169. The A is 169. And the angle of A is going to be the sine of A, obviously. And for B, I had to move my angle over here, but this is my angle of B. B, I'm going to take the sine of 76/63 over 277. And so now we just throw that up here in the calculator to give us the sine of 76/63 times 169 down here equals, divided by 277, it's going to be the 0.59. So now the only thing left is to take this inverse sine function, because once again this little decimal number is what we get when we calculate all of this. It'll just equal sine A, so we got to take the inverse sine to get it away from angle A, and that's going to give us 36.4 degrees. That's how you solve that one.